everyone. So today we're going to talk about this idea around linear versus non-linear functions and how to identify when one is non-linear or linear within a data table. And so we have been talking about linear functions, and we know that linear functions have a slope that is constant. So their slope doesn't change. So linear functions show a constant rate of change. So the slope doesn't change. So the slope stays the same. And that's between points. So as we go on our line, on the graph, when we look, it's the same distance between every single point on the line. Okay? So how do you know if it's non-linear? So if linear functions have the same rate or constant rate of change, your the nonlinear functions do not. Okay, so nonlinear have a rate of change that is not constant. So that means that the distance between the points could be all over the place. You could go up 1 over 2, up 3 over 4. You could even go down like in a negative. It doesn't make a line. So it doesn't create a line or have the constant rate of change. So the slope is different when we have something that is non-linear. Okay, so the slope is not constant. We can add that here. So slope changes between points. Okay, all right, so what does this mean when we see it in like a data table? How would this look for us when we're looking at slope? And so we can talk about linear and non-linear by looking at some tables. So my first table has X and Y values, and we have 3 over 40. We have 6 over 32. We have 9 over 24. And in the last one, we have 12 over 16. So let's talk about this rate of change and whether or not this is linear or non-linear. So when we look at this, we're going to be talking about the different moving from the x values and the y values so we can identify what the slope is. So to get from 3 to 6, we are adding 2. To get from adding 3. Oh my gosh, I can't add right now. To get from 6 to 9, we are adding 3. To get from 9 to 12, we are also adding 3. So every single time on this, we add 3. So far, the rate of change on x is constant. So now we'll look at the bottom. To get from 40 to 32, we subtract 8. To get from 32 to 24, we subtract 8. To get from 24 to 16, you are also subtracting 8. So our rate of change here says that as x increases by 3, y is decreasing by 8. So as x increases by 3, y decreases by 8. This change, or this rate of change, is constant. So this table is a linear table. So this is linear because of the rate of change. Okay, now let's look at another example. This example is going to show you what it means to be non-linear. So we're going to start again by having x values and y values. Our first one is 1 over 2, 3 over 11, 5 over 33, and last but not least, we have 7 over 88. So we're going to look at this and start to determine what the rate of change is on the x values. So let's start with x. In this example, our x values, to go from 1 to 3, we are adding 2. To go from 3 to 5, again, you're adding 2. So far, we're seeing 5 to 7, we're adding 2. Our x values are constant. So let's write that. As x increases by 2, let's talk about what happens to the y value. To go from 2 to 11, we added 9. But then from 11 to 33, that's 22. And to get from 33 to 88, that's what, 55? So we're adding 55. So the rate of change is not constant because as x increases by 2, y is increasing. Y increases by different values. Okay, so y is increasing by different values. This function, because it's not a constant rate of change, this one is non-linear. This is actually one word, but for some reason in my brain, I cannot write it as one word. It feels like it should be two. And it's really not. It is one word. So, so there you go. All right, let's do another example of rate of change before we get to some try-its here in just a little bit. Okay, so this table I'm going to show you has values of x and y again. And we're going to start to look at paying really close attention to the x and the y, and we'll figure out if it's linear or non-linear based on what we're seeing. So 3 over 1, 4 over 2, 5 over 3, and 6 over 4. Okay, let's go ahead and look at what we have going on in this example. There we go. Okay, so as 3 moves to 4, it's adding 1. 4 to 5 adds 1. 5 to 6 adds 1. So far, we're seeing that as x increases by 1, we're going to look and see what happens to the y values. The y values, 1 to 2 is adding 1. Oh, 2 to 3 is adding 1. And 3 to 4 is adding 1. Y increases by 1. So we've got a 1 over 1 situation happening here. So this example here is linear because it has a constant rate of change. The change in the x is consistent with what's happening to the numbers on the bottom. There's no change. Okay, we're going to do one more example before I give you your try-its. So one more example. This is example D. Example D. We again have x and y values. There they are. 2 over 4. And 5 over 7. And then we are going to move to 8 over 12. And 11 over 19. Okay, so let's start to take a look at our values here and see what happens with our rate of change. All right, so 2 to 5, that is adding 3. And 5 to 8, that is also adding 3. 8, 10, 11, that's adding 3. So as x increases by 3, what is happening to the y? The y value, let's take a look. 4 to 7, that's adding 3. 7 to 12, that's adding 5. 12 to 19, that adds 7. So this is not okay, it's different, right? Even though there is kind of a pattern, right? Like a pattern plus 2, that doesn't matter. It's not a constant number that's the same every single time, like on the x. So as x increases by 3, y is actually increasing by different amounts. So this does not work. So the y values increase by different amounts. So this one shows a non-linear function. Okay, it is your turn to do some try-its. So we're gonna write those down right now. Okay, so your try-its for today. Oops, I scrolled too far. There we go. All right, try-it number 1. Try-it number 1 has a table that shows x values and y values. Imagine that, more x and y values. And it shows 2 and negative 8. I love how your try-its are always harder than the ones we do in the problems. I don't know why they do that to you. 4 and negative 4. 6 and 0. And last but not least, 8 and 4. So they saved the negatives just for you. I know you love that oh so much. Okay, and then number 2. Number 2, x and y. We have 0 and 25. Ooh, look, there's the slope and the y-intercept. And then we have 3 and 20. And we have 7 and 15. And then last but not least, 12 and 10. So we have various different amounts here. Let's hit pause right now so you don't hear me solving. And then when you are ready, come on back and check your work. All right. So to move from 2 to 4, we are adding 2. 4 to 6, add 2. 6 to 8, add 2. All right, let's look at our next one. Negative 8 to negative 4. We are increasing because we're moving closer towards 0, so this is adding 4. Negative 4 to 0, that adds 4. 0 to 4, that also adds 4. So this one is linear. It's linear because x add 2 and y is add 4. So it is constant rate of change. Okay, and our last one that we're going to look at is number 2. Let's check this one. As we move from 0 to 3, we add 3. Oh, add 4. Add 5. So you can already see right away, minus 5, and minus 5. This one is non-linear. This one's non-linear because x varies, y varies. Nope. Y is minus 5. All right. So now it is your turn to answer your essential question. How do we identify if something is linear or nonlinear from a table? And then I would like for you to please rate your level of understanding out to the side. And then when you are finished, you can come on back to the Google Meet and ask for help, or you may go on and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.